All right, so let's try 33 and 7.7, which is one of these like little proofing things. So we want to take and demonstrate that 1 plus, 1 plus tangent squared of theta is secant squared of theta using sine squared of theta plus cosine squared of theta equals 1. Cool? All right, so first things first, I need to kind of motivate the direction that I'm going to take for this. Okay? So one thing you could notice is, let's see. I could notice there's kind of two things on this side, right? And there's two things added on that side. So that would sort of clue me in that this stuff, left-hand side, right, of the result might be left-hand side of the thing I started with. You guys see that? Okay, so the next thing I'm going to start with is just thinking about what do I know here. So I know sines and cosines, and this thing has tangents and secants in it. So let me kind of pop those out of there. So what's tangent? Okay, so tangent squared is going to be sine theta divided by cosine theta, and then square the pieces, right? So sine squared over cosine squared?
And secant is 1 over cosine.
Okay, and there's secant 1 over cosine. So this is 1 over cosine squared of theta. Okay, so now that I've seen that, right, it looks like I ended up with lots of cosine squareds on the bottom there. You guys see that? So the first thing I'm going to do is I'm going to start with, and I'm going to very carefully write all of this down for you guys. So this is what I kind of expect for an answer. So we know sine squared of theta plus cosine squared of theta is 1. Period. Cool. If you want to give a source for that information, like a Wikipedia-style citation link, have at it. Right? If you're going to do that, I'd do something like this. Like just some kind of little note to myself, hey, remember there's a Pythagorean theorem thing for that. Cool? You could chase that all the way to the bottom if you want. Whether you want to do that or not depends on you. It also depends on the person you're talking to. Okay? So I'm going to just start with, we know this because I think you guys all know this. Period. Great. Now, what do I think the next step ought to be?
Sine squared theta plus cosine squared, I'm sorry, 1 plus tangent squared theta equals secant squared theta.
Yeah. Good thought. Like that's the other thing, right? So my hope is that I'm going to start with this and end with that.
Okay.
You guys see that? So my hopeful thing here is that this is going to end in a statement that says something like, so 1 plus tangent squared equals secant squared.
Right at the red.
Yeah. So I'm going to use the red to motivate what I'm going to do. Because right now this is the only thing I know. You guys see that? Like, this is what I'm going for, but I don't know that yet. So what does the red tell me might have to happen here?
Can we?
Division by cosine squared.
I was say, can we subtract and put 1 on the one side and secant on the other?
Oh, for this guy?
Yeah.
You could.
Yeah, then divide by cosine
Yeah.
squared theta.
Yeah, I think I'm just going to divide by cosine squared of theta anyway. You guys see that? So dividing by cosine squared of theta, we obtain, what do you get?
Secant squared.
So you get sine squared of theta divided by cosine squared of theta plus, what's your next guy?
1.
Yeah, 1, right? I'm gonna write that out. I'm gonna write cosine squared of theta divided by cosine squared of theta. Okay, see this?
Over
Not yet, right? Because it equals what?
1 over cosine squared
And that equals 1 over cosine, cosine squared of theta. You guys all with me on that? So what am I going to do next? What's my next step here?
Convert it back.
Yeah, not convert maybe, but simplify a little bit and then convert. You guys see that?
Yeah.
So oops, simplify is maybe a poor word, right? Because I'm kind of talking, right? So what should I be saying here?
Sine squared theta over cosine squared theta equals tangent squared theta.
Okay, so I might say, we now observe, right? Sine squared of theta over cosine squared of theta is sine of theta over cosine of theta all squared, which is,
Tangent squared.
this is tangent squared of theta. So that's one of the things I'm observing. What else should I be observing?
Cosine squared theta over cosine squared theta equals 1.
Cosine squared of theta over cosine squared of theta is 1. So I'm observing that, and this, and
1 over cosine squared theta equals secant.
1 over cosine squared of theta is, is what?
Secant squared theta.
Secant squared of theta. Okay, see that? Now,
Therefore, you get.
perfect. Therefore, or so, right? So the thing you wanted at the beginning. 1 plus tangent squared of theta equals secant squared of theta. Cool, thanks. Questions, concerns, deals? So right now, all of what's written on the board, wait, not all of, but most of, what do I circle here? What's my answer? Sort of ends there
Begins with we.
and begins with this we know statement. And you don't have to write this like a crazy person with this we crap. That's just because I'm standing in front of you guys. Cool. You can make this passive tone, which is usually what most people do. So to make this passive tone, you would sort of say, it is known, right? Dividing by cosine squared of theta, one could observe, or some other BS like this. So make this your own. However you do that is okay. You just need to communicate with your audience the thing you're trying to demonstrate. Cool? And when I'm doing these, like if I'm writing proofs, I'll often fiddle out the exact, like how is this thing gonna go, kind of in the margin, and then write all this down after I know exactly how it goes. You guys see that? I kind of used the red thoughts to guide me as I was writing, but that's only because I sort of knew where I was going to go. Cool? All right. So, Gabe's asking very reasonably. So, in the end here, I ended up with 1 plus tangent squared is secant squared. Is that an identity? Yes. Can we use it for things? Yes. This is the key behind a technique called trig substitution in Algebra 2, and you need it. But there's a whole mess of these things that look a little bit like the Pythagorean theorem. They all come out of sine squared plus cosine squared is 1. And so if I need to use one, usually I just do this. I shorten this whole thing out to, right, this guy. I'm going to write that as s squared plus c squared is 1. And then if I need one where there's a 1 plus, right? Well, I'll just slap this whole thing with a divide by c squared. And I'll get s squared over c squared plus 1 is 1 over c squared. Right? And then that's tangent squared plus 1 is secant squared. Cool? If I need one that looks a little different, I'll divide by something else. Or maybe multiply through by something. Cool? So yeah, put this little thing in your bag of tricks, and it might be useful just to remember that this guy is where all of those come from. They all come from the Pythagorean identity, and you can get all the others that look similar by dividing by something or maybe multiplying by something. Cool. Like if I wanted one with cotangent in it, how would I get that?
Divide by sine.
Yeah, divide by sine squared, right? So if I divide by sine squared, I'll get 1 plus cotangent squared is 1 over sine squared. So apparently 1 plus cotangent squared is
Cosecant.
cosecant. Cool? Questions, Steels? Yeah, those identities are all this one, just rearranged.